Hi, welcome to the video for Descartes' rule of signs. Our essential question is, how do we use Descartes' rule of signs to help us to find the zeros of a polynomial? So let's go ahead and start off first by explaining what Descartes' rule of signs is. Descartes' rule of signs, first thing we're assuming is that we have a polynomial and it's in descending order. So it's a sub n, x to the n, and then you'll notice the next one goes down by 1 degree because we subtract 1, all the way down until we get a sub 2x squared plus a sub 1x plus a sub 0. So this is a polynomial. It has real coefficients, and we're also going to state that a sub 0 is not 0. So we do have a constant term here on the end. So Descartes' rule of signs has two parts to it. Assuming that we have this polynomial, the number of positive real zeros of f is going to be either equal to the number of sign changes between the terms of our function, or it's going to be less than that number by an even integer. So if I have 3 sign changes, then if I go down by an even integer, it's possible that I might also only have 1 positive real zero. We'll look at that in a minute on an example. The second rule for Descartes, rule of signs, deals with the negative real zeros. The second rule says the number of negative real zeros of f is either equal to the number of sign changes of f of negative x. So notice for the negative real zeros we plug in negative x into the function, or less than that number by an even integer. Go ahead and pause, copy down this information, and then we will pick up with an example. Alright, welcome back. We're now doing example 1. We want to describe the possible real zeros of f of x equals 3x cubed minus 5x squared plus 6x minus 4. So let's start with part A of our Descartes rule of signs. Part A says we want to determine the number of sign changes of f of x. So this was going to help us to determine how many possible positive real zeros we have. So let's go ahead and look at our original function. And looking at the original function, I want to determine the sign changes. So between 3x cubed and negative 5x squared, there is a sign change. It went from positive to negative, so that's one sign change. From negative 5x squared to 6x, went from negative to positive, that's another sign change. And from positive 6x to negative 4, it went from a positive to a negative, so that's another one. So we had 3 sign changes on our original function, which means that we will have 3, these are the possibilities. We could have 3 positive real roots, or zeros, or if I take that number and I go down by an even integer, so if I go down by 2, I could also have only 1 positive real zero. So it's either 3 or 1. The change in possibilities always goes down by a number of 2. So this would be my possible positive real zeros. So now I go to the second part of Descartes' rule of signs, which says take the original function, and this time we want to plug in negative x everywhere there's an x. So we need to simplify that function by plugging in negative x and see what we get. So let's go ahead and do that. If I plug in negative x everywhere there's an x, plugging in negative x into the x cubed, and we've got minus 5, and then we're plugging in a negative x again, and we're squaring that, plus 6 times the negative x, minus 4. We're going to simplify this negative x cubed is negative x cubed, so we're going to end up with negative 3x cubed. Negative x squared becomes a positive x squared times a negative 5, so that remains a minus 5x squared. 6 times negative x is a minus 6x, and then minus 4. If you're a little confused by this, try expanding it out. It helps. Negative x times negative x times negative x. You get 3 negatives, that makes a negative. Over here, negative x times negative x. Again, I've got 3 negatives being multiplied, so I end up with a negative. This one you can see the 1 negative, so that became a negative. And this one, we didn't plug in a negative x because it was our constant term. Alright, so now that I've simplified plugging in the negative x, now we're going to look for our sign changes. So from the first term to the second term, a negative and a negative, it stayed the same, so there was no sign change. Go to the next one, negative 5x squared to negative 6x, again, no sign change. And then negative 6x to negative 4, again, no sign change. So we had 0 sign changes. So that means that we will have 0 negative real zeros. So there's no possibility, if I were to look at the graph of this, there's no possibility that it's crossing over here on the negative side. It would only be possibly crossing over here on the positive side. It might do it 3 times and it might only do it once. Go ahead and pause and finish copying this. We'll do one more example. Okay, we're back with example 2. Let's determine the number of possible positive and negative zeros or roots of the following function. We've got g of x is equal to x to the 5th minus 8x to the 4th plus 28x cubed plus 12x squared minus 64x plus 32. So we're going to start out figuring out our possible positive zeros. How many do we possibly have? So to start out, we're going to take a look at our original function, and we need to figure out all of the sign changes. Where are the signs changing? And if there is a missing term, you would be putting a 0 in that place, so we consider if there's a 0 in that spot, then there is no sign change, because 0 is neither positive nor negative. But we're not missing any, so we don't have to worry about that on this one. Go ahead and pause, see if you can figure out how many sign changes, and then we'll be right back. Okay, so let's check out the sign changes that you just found. Sign change here? Yes. Sign change here? Negative to positive? Yes. Sign change from positive to positive? Nope. Sign change from positive to negative? Yes. Sign change from negative to positive? Yes. So how many sign changes did we have? If you said we had 4 sign changes, you are absolutely correct. So because we had 4 sign changes, we have 4 possible positive real zeros or roots. Now, it's possible that we have 4 of them, but we might only have, if I go down by an even integer, 4 take away 2 is 2. So we might only have 2 possible positive real zeros. Or there's even a possibility that if I go down by an even integer again, that I might have 0 possible positive real zeros. Now, how does this help me? Because when I'm looking at, remember the night before we did that rational root theorem where we figured out how many possible roots there were, and we ended up with positives and negatives. If I find one positive zero or root that works when I do my synthetic division, then that means there has to be another one, because it has to be an even number according to this. If I find 3 of them, then I know there has to be a 4th one. So that kind of tells me what numbers to try, whether to try positive or negative numbers when I'm doing my synthetic division. So it really does help. Alright, now that I've done this, now we want to try to find our possible negative zeros. And do you remember what we do to do that? If you said we take the function and we plug in negative x, you are absolutely right. So if you would, go ahead and take this function up here, x to the 5th minus 8x to the 4th plus 28x cubed plus 12x squared minus 64x plus 32. Plug in negative x and simplify and see what you get. And then come right back and see if you got what I got. Okay, check it out. Now notice I showed what it looks like if you expand it out. Negative x to the 5th gives me negative x to the 5th. Minus 8 times negative x to the 4th gives me minus 8x to the 4th. Remember, when I raise something a negative to an odd power, it always comes out negative. If I raise a negative to an even power, it comes out positive. This one had a negative though, so then it was negative 8. So I expanded it out if you need to see that. Anyway, we ended up with negative x to the 5th minus 8x to the 4th minus 28x cubed plus 12x squared plus 64x plus 32. So now we are looking for our sign changes, because it's Descartes' rule of signs. So let's look. Right here, negative to a negative, no sign change. Negative to a negative, no sign change. Negative to a positive, yes, we have a sign change. So far we've got 1. Positive to a positive, no. Positive to a positive, no. So how many sign changes did we have? We had 1 sign change. So that means that we have 1 possible negative real zero. If I go down by 2 from that, I get negative 1. You can't have a negative 1 possibility. So I only have the possibility of 1 negative real zero. So I need to be looking for one of my answers that's going to be negative. And that's what that would tell me. Alright, go ahead and pause. Finish up your notes, and I hope you have a very good evening. And we'll see you tomorrow.